Correlation is a function mapping a pair of random variables to one number between -1 and 1, defined as follows.
What?
This is a formal mathematical definition of the word. We rarely think of it, if ever, when we hear it in speech.
He analyzed historic data from around the world and found no correlation between a growing population and a decrease in standards of living.
They can't really prove the correlation between a super high SAT score and a successful Google employee.
But when you look above that level, it's remarkable how weak is the correlation between success and intelligence.
By the way, the last person is who we thank for financially supporting Quanta. Anyway, when we use the word correlation, we often mean the extent to which two or more things are related to each other. Correlation. We don't put a number to this extent though. Here's an example. I have collected information about a few people weights and average running time per week. It does not look like it is two completely independent things. It looks like the more a person runs, the less is his or her weight. In this case, we say that the two things are negatively correlated. Guess what is positive correlation then? For now, we're actually good to go with this intuitive understanding of the word. So that is almost all I want to say. Well, and by the way, these kinds of plots with dots on them are called scatter plots. They help visualize the data, i.e. information that you have. For example, once you have this scatter plot, you can try to tell if there is any correlation. And once you have done that, you can attempt to derive conclusions. This is where you have to be careful. For example, in the scatter plot here, you cannot conclude that if you don't run, you'll gain weight, for example. Of course, you will get to practice more, but as a rule of thumb, be careful.